All right, I am going to demonstrate how to solve a problem using any generic right triangle. So these are the types of problems that say like if theta is an angle in the blank quadrant, and then they give you one of the trig function relationships, and they ask you to find a set of others. Okay, so for my example, I'm going to say that theta is an angle in the third quadrant, and the information I'm going to give you is that cotangent of theta equals a over 5. Okay, if this is my situation, I know that 5 and a are not values on the unit circle, so that tells me that I'm going to need to draw a triangle. It's in the third quadrant, so I know that I'm going to be down here in quadrant 3. And when I draw my triangle, remember you always want to include the x-axis as one of your legs. So theta is the angle closest to the origin, my hypotenuse is the diagonal, and then I have these two legs. So I was told that cotangent was a over 5. I know that cotangent is adjacent over opposite. So my adjacent side is a, and my opposite side is 5. Before I go any further, I want to ask myself, what do I know about positive and negatives, though, in terms of the number line? So if I think of the x-axis and the y-axis as a number line, I know that values on this side of the y-axis are positive, while values going below the x-axis are negative. And then going from side to side, I know that values on the left of the number line are negative, and I know that values on the right are positive. So these are going to be positive. So based on my little pluses and minuses, I know that a is actually a negative value, and in addition, 5 is a negative value. And that shouldn't be that surprising because I also know that quadrant 3 is negative x and negative y. So all of this makes sense. Keeping in mind that your hypotenuse, no matter where it is, the hypotenuse will always be positive. So I need to figure out what the hypotenuse is, actually. And to do that, I'm going to use the Pythagorean theorem. So negative a squared plus negative 5 squared is going to equal c squared, where c is my hypotenuse. Negative a times negative a is just a squared, because a negative times a negative is a positive, plus negative 5 times negative 5 is actually positive 25, and that's actually equal to c squared. Now I can take the square root of both sides. So c equals the square root of a squared plus 25. And because I have a plus sign inside the square root, that means I cannot simplify this any further. So do not make the mistake of trying to do that. My c term is radical a squared plus 25. Now, all of that was great, but the whole point of getting this triangle was so that we could figure out some extra values. So now I'm going to find the exact values for the sine of theta, for cosine of theta, for secant of theta, and cosecant of theta. Okay, sine of theta. Well, sine of theta is going to be opposite over hypotenuse. So the opposite side is negative 5, and the hypotenuse is radical a squared plus 25. Alarm bells should be going off because we cannot have a radical in the denominator. So this is actually going to be negative 5 over radical a squared plus 25. And I'm going to multiply times a fancy 1 in order to simplify this expression. When I do that, I'm going to get negative 5 radical a squared plus 25 all over a squared plus 25, because when you multiply two identical terms that are both being square rooted, you're going to end up with just the original. Then for cosine of theta, cosine I know is adjacent over hypotenuse, so it's going to be negative a over radical a squared plus 25. Again, exact same process. This is going to have to get simplified because I have a radical in the denominator. So when I follow that, my final answer is actually going to be negative a radical a squared plus 25 all over a squared plus 25. Some people might be tempted to try to simplify here, but resist that temptation because this is an expression, an addition expression, and I can't simplify there. So that is cosine. This was sine. Okay, secant is going to be hypotenuse over adjacent, and that's going to be a lot easier because now my hypotenuse is going to be in the numerator, so it'll be radical a squared plus 25 divided by negative a. I'm going to move the negative out to the front of the fraction. That is my final answer. And cosecant of theta is going to be hypotenuse over opposite, so it'll be radical a squared plus 25 divided by negative 5. Again, my negative I'm going to put out in the front of the fraction, and there are my final answers. So here would be the complete problem for this generic right triangle.